Hello everyone, Mr. Quality Guy here, back to you with another video, and today's topic we're going to be talking about kind of one of my favorites and kind of one that gets a lot of people in trouble. We're going to talk about correlation and causation and what's the difference between them. So correlation and causation, though they tend to be related, doesn't necessarily mean one another. While causation and correlation can exist at the same time, correlation does not imply causation. Causation explicitly applies to cases where action A causes outcome B. On the other hand, correlation is simply a relationship. So what does that mean? So, for example, if I were to run over a nail and I get a flat tire, well, the action of me running over the nail is the causation of the flat tire. The nail is not the causation. It's the action of me running over the nail becomes the causation, because the nail is an inanimate object. It cannot physically do anything that is not imparted upon it. So, what does that mean for quality? So in quality, we need to understand that when we're doing our 5Y to figure out where the issue lies, is that we are finding the actual causation and we're not finding correlations. Correlations can tend to be red herrings, but also could be useful in some cases. So if you notice certain things happen all at the same time, that can lead you down to a path where you can go, okay, it is one of these actions is the causation and the rest are correlation. So, for example, if this failure only happens when this, and this are present, okay, then we need to know, are these all causations together in tandem, or is one a specific cause and the others are correlated to that cause? Now this is also used in what's known as correlation studies. So correlation studies are actually kind of different and weird, but they're used a lot in quality. So a correlation study is where you're going two different people, generally in two different plants, are going to measure the same exact parts. So the parts will be labeled, 1, 2, 3, 4, 5, etc. Plant A will measure these parts and bring the data together, and plant B will measure these parts and bring the data together, and they will see where they differ. Now ideally, everything what plant A measures, plant B should get as well, but that's almost never the case, because you're going to have differences in machine settings. You're going to have differences in machines in general, because no two machines are going to be the same. No two operators are going to be the same. So, and this is where we then communicate with each other and say, hey, what settings do you have for this? And then we try to match our settings to get a better, to become more cohesive in the way we are measuring things. So correlation and causation are definitely very, very important topics. Ones that can get us really into the right thing. So, that is a video on correlation and causation. I hope you guys enjoy, and thank you for watching.